Good evening, classmate. I will be discussing on how we will calculate the multiple regression analysis and simple linear regression analysis. We have here a formula, y is equal to b naught plus b sub 1x. We will use this in our population parameter, while our y hat is equal to b naught or b sub 0 plus b sub 1 X. We use this in our sample statistics. And then we have here example. Oops. Uh, Number of hours studied is our X, and uh, or independent variable, and grade on exam will be our dependent variable or our Y. There are three ways on how to calculate this. First, calculate simple linear regression and multiple linear regression. First is by hand. I will not show you now. We will not do it now because it is too long, and to, and I'm sure you don't want to do it because ang haba talaga. Uh, in getting the slope, b sub 1 is equal to the sample total number of our data times the summation of x and y minus summation of x times summation of y over uh, total number of our data times the summation of x squared minus x squared. While we will use b naught minus is equal to the average of y minus slope times the average of x. So when I computed this by hand, I got a slope of 4.71 and my y-intercept is 55.23. The second way on how to calculate this one is using Excel. So if you're using a laptop there, please do it with me. Click insert, click scattered, click the first one. Ayun. You got a blank chart here. Then, if you click and nothing happens, it is still okay. You will get click the sign, select data, then it will show you this. Click add, then uh, input our x value. Kung meron pa talaga siyang value, then input it. So, mm, the next is our y value. Then click OK. Click OK. Then this is what we've got. So in getting our line regression or uh, we got click layout, then click trend line, click more trend line, then make it sure linear here, then click display equation in chart, and then display r squared, then close. Now here we got this one. Transfer this to here so that it is easily to see. This is our line of regression. We get it positive line. Uh, when we get a positive correlation or relationship, it means the one tends to go up and the elements tends to go up also. If we get a negative correlation, I mean this our line of regression go down like that. One goes up and the other one tends to go down. Go down and vice versa. Then if this line of regression goes straight like that, we got a flat line or no correlation at all or no relationship at all. Parang kayo, di ba? True. And then, next is multiple regression. Multiple regression is the uh, extension of simple regression and allows us to uh, consider more variable to get a better prediction. For example, here we add GPA, the X1, X2 is age like that. Uh, I will use this same data to show you. So click data analysis. I data only. Then click here. If you don't have data analysis here, you can just click here and then click Excel option, click add-ins, then click data analysis, then restart your PC. Then back here, click data analysis, then choose regression, then click OK, and then input our Y range, then click our X range, then click OK. If you label this when you doing in the remember the series the X value like that. If you included this hours of studies or grade of exam, click the label here. But if because we did not include, then leave it like that. So click OK. Then here. Multiple regression here is the coefficient of multiple correlation. The correlation we get in simple linear regression where we are comparing one x in one line. But if two variables, the one that I said a while back, the correlation between two variables, the value is going to be between -1 and +1. And then, our multiple are here, this tells you between 0 and +1, the strength of the relationship between all of our predictor variable and our single dependent variable. And then our R squared here, a measure of the strength of the predictive power of your regression model because it factors in the number of predictors variables that we've included. In addition of that, if we add the x1, x2, x3 like that, the one that I mentioned a while back, r is r squared here always goes up when we include that new predicted variables. And then our adjusted r squared here adjusts for the number of terms in a model. We will use this if more than one x variable. And then our observation, this is our sample size. So in using SPSS and to understand more, Sir Elias will discuss. Thank you.